In this session, let us learn about SciPy graphs. Working with graphs. Graphs are an essential data structure. SciPy provides us with the module scipy.space.cs graph for working with such data structures. Adjacency matrix. Adjacency matrix is a NXN matrix where n is the number of elements in a graph and the values represents the connection between the elements. See here A, B, C 1, 2. For a graph like the with the elements A, B and C, the connections are A and B are connected with weight 1, A and C are connected with weight 2, C and B is connected. The adjacent matrix would now look like this: A, B, C, A 0, 1, 2, B 1, 0, 0, C 2, 0, 0. Below follow some of the most used methods for working with adjacent matrix. Connected components. Find all of the connected components with the connected underscore components method. See, import NumPy by using this connected matrix CSR underscore matrix connected underscore component method. The result returns is one array 0, 0, 0, data type is integer 32. dig k-stra. Use the dig k-stra method to find the shortest path in graph from one element to another. It takes following arguments: return underscore procedures Boolean true to return whole path of traversal, otherwise false. Indices. Index of the element to return all paths from the element only. Limit. Maximum weight of path. See example, find the shortest path from element 1 to 2. See, by printing dig k-stra new array return underscore predecessors is equal true, indices is equal 0, the result returns is array 0, 1, 2, array minus 999 0, 0, data type is integer. Floyd Warshall. Use the Floyd underscore Warshall method to find shortest path between all pairs of elements. See, find the shortest path between all pairs of elements by using Floyd underscore Warshall. See, if we write and execute this code by Floyd underscore Warshall method, the result returns this. Bellman-Ford. Bellman underscore Ford method can also find the shortest path between all pairs of elements, but this method can handle negative weights as well. For shortest path from element 1 to 2 with given graph with a negative weight. See here, if we execute this code, the result returns this. It shows negative weight. Depth first order. The depth underscore first underscore order method returns a depth first traversal from a node. This function takes following arguments: the graph, the starting element to traverse graph from. See the example, traverse the graph depth first to give adjacency matrix. See, if we execute this code, the result returns this. Breadth first order. The breadth underscore first underscore order method returns a breadth first traversal from a node. This function takes following arguments: the graph, the starting elements to traverse graph from. See the example, traverse the graph breadth first to give adjacency matrix. See, by executing this code, the result returns this. Okay friends, this is the end of part 5 scientific graphs. In next video, let us learn about another topic, SciPy spatial data. If you like our program, please like, subscribe and press bell icon for our next part video updates. Thank you friends. Meet you in next video. All the best.